frameworks, but they are like just like a uh, interfaces. How you can do it using the Google Colab only. Like you have to manually do lot of stuffs for other things, and they break so many times, and there are no concrete frameworks which are written for other cases or other generative cases. When it comes to the large language models, there are mainly two, but there are more than two also. Like for example, LangChain and Llama Index are quite popular, and they do have their own strengths and weaknesses, because both the frameworks are written something keeping some focus in their mind, or they meant to solve specific problems which are faced during these frameworks. Okay, let's go to the next slide, then we'll get the more idea. What are these frameworks are meant to do? These frameworks bridge the gap between sophisticated models which are over there with the real world data and applications. When I say real world data and applications, what it means is that there is a model. Specifically, these large language models are existing, but I have my own data and I have my own application case type, like whatever may be my need of my application to develop. Like example, a chatbot in LLM case. But how do I integrate this the strength of a large language model to a chatbot and with along with my data? How can I add all these things? When this question came, the people around the world, the developer community, what they did is that they came up with certain frameworks, LangChain and Llama Index. This is not limited to them. There are other frameworks like DSPY, semantic kernel, prompt flow, and haystack. Yeah, like this, there are several frameworks, but they are not quite popular. But recently, the Microsoft has launched its own framework, the prompt flow, which is just I mentioned, which is going to become one of the offerings from the Microsoft for their products. That is not a more generic, like you cannot use it with non-Microsoft applications. But if you are in a Microsoft environment, then you doesn't need LangChain or Llama Index. They do have their own framework, which is more, what you can say, easily fits into their environment. They have developed that one. And since it is not um, what I can say, not more generic. I'm not going to cover that one over here. But if you guys are interested, you guys can go to the Microsoft Prompt Flow and you can uh, understand more about it or work with that one more. But in general, why LangChain and Llama Index? Because they are more generic, they are supported, or they are able to, with them, you are able to work with most of the open source large language models which are offered from the Hugging Face. Or if you host a large language model in your local computer, you can use it. Or the third party APIs like GPT-4, Gemini, Cohere, or whatever the third party is offering, you can use it seamlessly with these tools. And they keep on updating their tools. This is one of the important basic things we need to understand, that a library should get updated frequently. Otherwise, if there are no updations from the library side, it becomes irrelevant. Such a frameworks will become irrelevant and they will not be having most recent development into their integrations. That becomes one of the drawbacks. But these libraries, especially LangChain and Llama Index, are being releases. If you go to their releases, you see every week they have a release. Every 2 weeks, 3 weeks, you will see the release in one of their models. Okay, what is LangChain? When it comes, LangChain, the name itself indicates it's a chain. It try to build a chain. Chain can be of any type, like it can be a tree format, it can be a sequential format, whatever kind of you imagine. LangChain tries to make it or tries to create it. The strength of the LangChain is ability to integrate with LLMs of any kind. It can connect powerful languages, databases, APIs, tools, whatever you take in the world. It able to connect to all of them, and then you can create a chain out of it. As I mentioned, it can be a tree structure, it can be a linear structure. Just there is no limit to your imagination. It can do it. That's the strength of it. It allows multi-step like reasoning. If, for example, if when I demonstrate in one of my notebook how the chains are created and how the multi-step reasoning can be integrated into it. And it can also use it for optimizing the prompts. Prompt is a way to communicate with these LLMs. Yeah, it can do a lot of things. And the core functionality of these are chains, multi-step LLMs. Memory is quite essential when we use it for the chatbot. And also, I will be showing a demo where how we can store the memory and use it. And prompt management, as I mentioned, it is one of the way to communicate with the LLM, and it needs to be optimized. And data handling and pre-processing, like it can handle so many varieties. Like if I have a PDF, then how do I pre-process it before feeding it to the LLMs? That's the RAG. It's a concept of RAG, retrieval augment generation, which will be covered by one of the uh, other colleague. So then all these things integration can be done through the LangChain. LangChain is so far in one way. So this is just a given overview. What are the areas it covers? One is data connections, like data loaders, document transformers, embedding models, vector stores, retrievers. All those things comes under data connection. Then model I/O, like prompts, means model I/O means model input and output. We feed model or send a prompt and get the response from that one. We do the parsers. I show how the parsers can be manipulated or generated language models like any LLM. Then we have a chains. Chains is nothing but a series of sequence of tasks which we want to connect, like load the document, then pre-process it, then embed it, then store it in a vector database, then do the search on that one, or just create a prompt, then send it to LLM, get a reply back from it. Based upon that replay, again create one more prompt and send it to LLM. Like this kind of a several things you can create it. Memory is quite essential when you have a multi-term chart. Single term chart is something like when you send a request and get a reply back. But when we say multi-term, it is like back and forth continuous conversation will happen the way we humans communicate. That is multi-terms. Then agents, tools. Agents is one of the framework which is initiated by the LangChain, and it become quite popular. And there are several frameworks generated around it, like agents. One is Crew AI, another is Agent, Autogen. There are several others, but these are quite popular. People have been able to work with them. Tools is nothing but any functions, auxiliary functions which are there to support the LLM. Like for example, I need a calculator. LLMs are very bad at the mathematics. Then if I want to use a calculator, then I can give calculator as a tool to the LLM to say that whenever you have any mathematical calculation, use this tool. It does it. That is known as a tools or API, function calling or API calling, people also call it. Most of these models support it. And agent is nothing but you create an entity who is doing the sole responsible work. um, this is a bit beyond the scope of this framework, but it's a concept which I wanted to tell is that agent is having a tool, a LLM, and a task to do, and it has a responsibility. Like a task is a responsibility, but it has a responsibility to check by itself. Okay, so this is an agent task. Using an LLM, using the given tools, it makes a task that is known as an agent. I can create several agents and communicate between them. That is multi-agent architecture. That is the AI and AutoAgent deals with. Then the key components of LangChain are combine multiple components to complex workflows, um, connected links of workflow diagrams, and then autonomous actors that use LLM to determine actions, robot or AI agent, hmm, define the like the memory, conversation history, manage or optimize input prompts and LLMs like prompts, document loaders, and all this. Whatever I have shown in the image, that is the same thing. This is also same thing, but here how they are getting connected each other, which will more what is that? More higher view or more elegant view. Like I have several input providers like OpenAI, Hugging Face, um,
Russell, you are muted.
oh, sorry. Uh, so we have the input components like OpenAI, Hugging Face, which are the components externally available. Then I can have the memory component. Then I have a prompt component, and then I have several toolkits and agents. All these things creates a chain, final chain, and those can be used for several applications like question answering, summarization, chatbot, querying a tabular data, interacting with APIs, code understanding, all these things can be achieved with the LangChain. Again, this is the same thing, whatever the previous, this one I showed, the what are the main uses of LangChain. Then the another framework, Llama Index, which is of also of similar kind. Uh, Again, it has the uh, same capability as the LangChain doesn't differ much, nothing much, but there are some specific differences which I can show it at the end of the slide. That what are the difference between them? Like Llama Index, it is also a similar framework which can connect with the data ingestions, raw files, vector DBs or databases of any kind, and then it has communicate with the LAN chain also. This is one of the more advantage of Llama Index, that it seamlessly works between LAN chain and Llama Index. Why we need to connect it with the LAN chain? Because Llama Index is very good at RAG. It has a very good components at a RAG. Llama Index was developed actually for the RAG to solve so many problems of RAG, retrieval augment generation, which the LangChain was not able to address it. LangChain created a framework around it, but it did not focus on specific thing. It was just a framework to help around all these work. Like if I want to build a application, how do I build it? It just created a chains and then gave the all the control over to the user. Whatever you want to do it, however you want to optimize, you can optimize it. But it doesn't gave a framework which is specifically meant for RAG. But Llama Index did that one. It realized there is a lack of framework which specifically meant for RAG or to fine control the RAG things. Then the developers of Llama Index, what they did is they came up with one more framework which is RAG and which is able to communicate with LangChain. What it is mean that you can build some part of your whole application using a Llama Index, the other part using a LangChain, such a way that the both together can exist, means best of both, you can say. So Llama Index use cases is also same thing, like you can use it for the chatbots, building the knowledge bases, creating AI for documentations and all those things, whatever the LangChain can do. Comparing LangChain and Llama Index, as I mentioned, the focus of the um, LangChain is flow, like how the flow happens, what are the chains it can, and it provides a tool for chaining the calls, handles memory, agents, and all things. But Llama Index is specially for data integration and retrieval. That is RAG. It focuses more on data ingestion and indexing. Like why the indexing is so important, you guys will get to know that the indexing is major part of a RAG. And if you want to optimize a RAG, you need finer control over indexing, the way data is ingested, how do we retrieve it, how the search of the data within the vector database happens. All those things are handled by this framework. So it is very well created in Llama Index, and that is the Llama Index optimizers. This is higher overview that indexing and querying is the same, but remaining things are different. Tools agent chains even exist in Llama Index, but the focus is different. Like I have not shown here, but they exist in both of them, and there is no much change in their way of behavior, structure, and anything. Yeah. Thank you for this being for this talk. If you guys have any questions, I'm happy to answer. Okay, let us move to the what is that practical applications. I'll show one by one using the LangChain so that you will get the feel of it. Okay, I hope everybody is seeing my screen with the collab notebook. The first is basic text generation. What is basic text generation? I'm here using Grok API because Grok offers the free services, and I'm using Mixel. There is no specific reason to use Mixel. Just I can use any model for this purpose because it's just a demonstration of how basic generation can be done using LangChain. So I have imported several libraries. One is related to ChatGrok, which is connecting the ChatGrok using the API, and the prompt template means create a promptlet, and then you can see that LLM chain, which chains together my API or my LLM model, my prompt, and the third one is just relevant to the Google Colab. It's not anything to do with the LangChain. So the first line says initialize the Grok LLM with Llama 3. Sorry, this is Mixtral. It can be anything. I thought I will use Llama 3 in the beginning, then I switch it to Mixtral. Okay. So this is Mixtral, which will just load that one using the chat drop model. Means I can set other parameters here. I have not selected, but whoever want to play around with the other parameter like top P, top K, and all those things can be uh, configured. If I have kept a temperature 0, it can be kept to from 1 to 0, anything value between them. Then I have created a prompt. Prompt has a two variables. One is input variable, means input variable is a query, and template is something which is fixed one. Write a short paragraph about topic, like the input variable will get into this topic and it becomes a prompt, and it will be given to the LLM. And finally, I have create here chain. You can see that LLM chain, LLM plus prompt. This is one way to create. There is another way to create in LangChain, that is uh, using the pipe operator, LLM pipe. Prompt, this can also be done. But this is for beginners, it becomes really hard to understand. But as you going forward, when you dive deep, advanced level of LangChain, then you will get to know about these things. because this is not simple. This one, there are several other things we will add. Uh, I don't want to confuse you guys. This is very simple. Like I have a LLM chain. I have given LLM to LLM, prompt to prompt, and it runs. And the question, topic of the question, like whatever the topic I have idea, artificial intelligence, then I'll say chain dot run. It will answer. Let us run this. Shall okay. The result is artificial intelligence refers to development of computer system, blah blah blah. It answered it. So it's a basic whatever I want to say, basic text generation. You ask a question, it generates, but it doesn't remember what was my previous question. Like in case of chat, we want to do it. For that one, we call it as a multi-turn conversation. So along with previous libraries, I have added two more libraries like conversation chain, conversation buffer memory. The conversation buffer memory just keeps the previous conversation into the memory. There are several ways to keep it. I have made it very simple here to get a grasp of it. And then conversation chain is it continues. And similarly, I load the model. Here I am using Llama 3 right now. Then I have created the conversation buffer memory. And I give three things to the conversation buffer memory. Then one is LLM, which LLM I'm using, the memory. Verbose is just to print. That is nothing to do with the this one. Just it will print in my screen every time a chat happens. Then I have a small function for chat with an AI and simulate conversation. This is just to simulate the conversation. Nothing to do with this one. But everything happens here only, like LLM, memory, and everything. Here you don't see a prompt. Here we are not going to work with a prompt because right now I want to keep it very simple. But for complicated applications where you want LLM to behave in a certain way, then you have to really create a prompt like a system message, then user message, and all those things will come. But that is bit advanced. You guys can, if you are interested, you guys can again try them. Let's run this one. So it is asking me, hello, how are you? How can I assist you? That is the answer from the question. Like the first query was, um, yeah, this is printed, just it is. Okay, I will say, can you tell me about language? I was like, returning the console. This is when I since I kept it verbose, it will print everything. Then it's the chain, lang chain. Yes, I'm familiar with it. It gave the, but again, it is asking a question. Can you tell me about other frameworks? Yes, it gave other frameworks, all those things. The answer may not be more what is that proper or accurate because depends upon the model and again the prompting and all those things. Just to give you guys an idea that it is keeping the flow. Uh, uh, what was let us have something which is relevant in the lang chain like yeah language lang chain is model in the university. Let me ask which team developed the lang chain. What is what developed the lang. Same thing it will answer, but I have asked for something from the previous. So the next one is, oh, I did not give the headings. Uh, this is chaining. It's chaining in lecture. So what is chaining in LangChain? If you go to the code, I have a question prompt, I have an answer prompt, and I have created a chain here. Question chain, Answer chain, verbose is just true. What it is does is first it asks the question prompt. Once the answer comes, it again asks one more question. Answer prompt. Please provide a detailed answer to the following question. Generate a thought-provoking question about the topic. Like the question prompt is creating something or generating something about a topic based upon topic. And based upon that topic, I generated some questions. I took them and then gave it again some more thing to do. So I can change them. Like I can have the several now do something else like extract these parameters from this one, these named entity recognition from this one, or inference something on top of whatever the generated one. Let us see. For example, again, I'm asking what is artificial intelligence. The topic is artificial intelligence. So the first goes generate a thought-provoking question about artificial intelligence. It generates few questions about the artificial intelligence, and I take those questions. Please provide detailed answer to those questions. Means I am generating a question from my LLM and again asking it to answer that one. So I'm doing a chain of work over here. Otherwise, if you have a chatbot, what you guys will be doing is that you send a question, you ask a like if the same topic is chosen, then you
So,
will ask. Yeah,
that's a mean chain of thought prompting, right?
yes, it's a chain of thought process. It is like that's why it is chaining everything. Like you ask a question, like generate a questions about this one. Once it generates, you copy them and again ask the same question to the or in normal in chat GPT, you ask like, can you generate an answer for the above generated question? Something like that. It uses internally that one. But when you want to do with LangChain, this is the way to do it. So this does that one. I can give any topic for it. It takes some time because it takes twice the go back and forth with the model. It takes so much time. I don't know. I don't know what is the reason behind it. It's taking so much time. Oh, my this one is not connected. Check the resources. Is, I think it just hung. I don't know what is. Oh, the previous session I did not end. That's the reason. Okay, now I got it. This session was running continuously. I'll show you why it is running. Because I have to type exit, quit, or buy anything, then only it will. I did not do that one. Now it added. Okay. It will not. Okay. Is here a thought-provoking question about artificial intelligence, and then these are the questions it generates. Write a thought-provoking question. The rise of artificial intelligence. Blah 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 blah. These are the questions which I, in conclusion, question whether to try to raise it. So you guys can go over this, and this is the final result. So this is the chain of thought. It does the chaining of those things. And this is what is output parser. Output parser is way to output a the once you ask a question to a LLM, how do I output it or the format of the output. Here I have created a response schema. You should do this one like the name of a person, the age of the person, list of the person, and where is my prompt. Okay, generate a information about a fictional person because I don't want it to be specific person. I said that you generate it, and then I said it to output in this structured format. So let us check how it does it. So this is the generated content, this is the output, and this is the way it has been. You will in stone 29 something. It created an fictional character and then it worked on it. And what is about this one? Okay, this is about um, reporter, content writer. This is bit more advanced and like that. So what I have done is that I have given a role like create a detailed blog post, outline the topic. These are the topics. This is my template, and then I have created a template out of it. This is a topic, and topic I'll be giving at the end, like the social media content, benefits of meditation, whatever. This one. Then it will take that topic, the platform. Platform I have mentioned Twitter. Topic is benefits of meditation. So it takes both of them as an input and creates a social media template out of it. This is social media template. What is it? It creates a three engaging social media posts for a platform, that is the Twitter, on a topic, benefits of meditation. For each post, should you be concise, catchy, and include relevant hashtags. And it goes back to the blog prompt. So social media prompt is created, blog prompt is created, and where is it? Social media prompt, LLM, social media prompt. So first I generate the social media chain, generate the blog post outline that will run based upon the topic. That is, this chain will be run like blog post chain. There are two chains, just to mention you guys. Blog post chain is different, social media chain is different. There are two chains which are independently working. It's like an agent, but it's not an agent. Agent structure is different because I have supplied tools. Here I am not supplying any tools, like the tools to go to internet and search. I'm not doing that one. I want it to generate based upon its own knowledge or the knowledge which is being trained on based upon that one. So blog post chain is created. Similarly, social media chain is created. Then I have generated a two function which does it. One is for the running the social blog post, and another to run the social media. Means once I generated the social media post, then I have to outline it or make it more beautiful. Let us check it, how it runs. So once I run it, it generate everything, blog post outline. First, I have to create an outline, and then based upon the outline, I created a social media content. Here are the three engaging social media posts, mindful moment, blah 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 blah. You guys can go over it. Because it is meant for a Twitter, it will be short with the hashtags and everything. So it's more this one. It's again a chain of thought, but here I have made it for a simple use case. Knowledge retrieval, I believe this is handled by the one of the other colleagues. I thought I will show it, but it's fine. Llama and Expo, it's not running. It has some issues. Not running issues. Okay, it has issues. Okay. Yeah, that's all from my side. If you guys any questions, let me know.
Thank you very much. It's a nice overview of Langshan and Lambda Index. Thanks.
If you guys have no questions, thank you for being the part of this session. I'll be sharing this notebook. You guys can work through it. Normally, if you want to anything in the coding world, you have to have a hands-on and work on a project which is gives a more way to think. Like this AI field is like creating or creativity field where you dream of something and you create out of it using the existing tools. That way you'll be able to learn more in this world. If you guys want to explore in that direction, yeah, be be ready to do hands on, get more details or what are the things possible from a framework and work more on it. Thank you all for being part of this session again. Thank you.
Yeah, you can all stay here because we have a RAG and prompt engineering session with Vijay. Yes, thank you, Bashan, for the session.
Should I do it now?
Yes, Vijay, you can start in 5 minutes. Yes, you can start. Bashan, if you want to drop off, you can drop off.
I'll stay for a while. I want to go through this. Okay. Yeah.
Okay, right, sure, sure.
Does the slide moves?
Continue, Vijay. It's good.
No. Just checking. Does the slide moves? Are the slides moving?
Yes, Vijay, yes.
Okay. Welcome everyone. I am myself Vijay, and I will going to take the topic of prompt engineering and RAG. So what is prompt? Prompt is the thing but the textual input which you give to the LLM so that it generates the output, or it is some step-by-step instructions which are given to the LLM. For example, you can see it is here. This is one kind of prompt. What is AI? It generated the output regarding to that topic. So there are different process of doing the prompt. First, we have to define the task like what we are going to do, like uh, writing email, writing a blog or something. Then we have to identify the inputs that are like what kind of blog you're writing, what email are you writing, the title of, example, title of the blog. Next, creating the detailed prompt, right? We write down all the points and create a prompt like what all we want to have in the example in the blog, what all we want to have it, like introduction, conclusion, this kind of things. We list them and write a prompt on it. And after writing the prompt, we run it and then we recheck it so that we read the results and rewrite the prompt if it is not so good for us. Example, that means we are refining the prompt. There are different types of prompts like uh, zero shot, few shot, chain of thought, and there are some other prompts too, like role playing, multiple choice questions, this kind of prompts. In zero shot prompt, it is nothing but just giving the input, like the one you saw here. This is a similar one. This is called as zero shot prompt. In few shot prompt, we'll give some examples. Like, can you see Chat GPT? This is the zero shot prompt. It will generate the output. in few short prompt, we will give some examples like hello. I'll show you. So this is the few short prompt where we give some examples like translate text to French example. Example here I given two tables and I asked translate this text to into the French. It has generated. See, you can see. Similarly, in chain of thought prompt, we are going to ask the ChatGPT to write. We give into the ChatGPT in detailed way. Example. Like this, we give the prompt like if we ask to write an article in AI, we'll give the steps which are like you should contain introduction. In introduction, what are the things you should be mentioned like that. So it gave everything. I'll show that in the code too. Like there are different use cases of prompt engineering. We can use the prompt engineering for chatbot and virtual assistants to provide give the relevant responses, and it can be used for text generations and question answering models. What are the significance of prompt engineering? Like it will give us the model will be improved very well, and it will quickly learn everything and remove the negativity of the output, can refine the output. I'll show you the code too. I connected to the GPU. Here I am installing transformers and bits and bytes accelerator so that I can use the larger models. And tokenizer and transformers are for tokenizer, tokenize the input prompt. And I've been using the Mistral 7B version 1. Here, load the API key. I kept it hidden. Here I give the prompt like my favorite condiment is. Then I tokenize the prompt, this input prompt using auto tokenizer, and the model will be Mr. 7B. And this will take to the GPU. Here I load the model. Here I use the 4-bit quantized model so that it can fit into the Colab. Else you will get some errors like section expired.
Can I ask a question here?
Yeah.
This loaded 4-bit, like in one of the sessions, one of the presenters talked about Q LoRa. So this is the same thing, like the quantizing, like
Yeah, similar one.
okay. Okay. So if we are doing it for our like this thing, so here we can use a 2-bit or 1-bit also, right? For the learning
For
purpose.
me, what I got is that for Mistral 7B version 1, this works. If I don't put this part, then it will not run. It will give some section expired error. It will
Okay.
stop at
Uh,
run half. It will run around till half, then it will stop.
okay.
Like
And,
no memory, that kind of error.
mhm.
Just loaded the model. Now in generating, I'll give the tokenizer prompt and I given max tokens as 200 so that it will be generate up to 200 tokens. Okay, something. Whatever here it is happening, like the tokenization happening right here is I can show it here. It is split into 3 tokens. Like what is the one token? Space and is the second token, and space and drag. This is the third token. It has generated 11 characters. That's what the meaning of tokens. After generating, we have to decode it, else it will be on the some other format like numerical. And here I print the response. My favorite condiment is something. Also written for few short prompt. Here I will give the role user and role assistant are the two examples. And these are the content. What is their favorite condiment? Until there is the answer to that. And I will ask the second question. Now I tokenize the prompt like I shown here. Here I generate the prompt and max token is 200. Here the in this model, open source models, the issue is that it will normally it will give the output with the given inputs like given what is a favorite condiment. It will print that one too. For that we have to optimize the output. I made that in this code. I'll show that. These are the two examples which I written the code like for zero shot and few shot. And for chain of thought, I will give us a task for everyone. Can use this code as an example. I will share this code. Prompt is nothing but whatever we give here, the input. Ask it to generate very well answers. If the prompt is good, then it will generate good. If you give something junk or input, it will give some junk output. Like here, I expect yes or no answer. You give the yes answer yes, and you started typing everything from the beginning again. So if we give the better prompt, yes, this how it will answer. Better the prompt, better will be the output. Next up is RAG. RAG is nothing but getting relevant data from the external storage and generate the response. Like in, if you give some input to the ChatGPT, like or LLM models, who won the T20 World Cup of 2024, it will say that I cannot provide the answer to that because it has a memory of up to around 2023, and this World Cup happened in 2024. So to overcome that, we go for retrieval argument generation, where RAG will have the data which are related to this topic stored in vector storage, and it will access to that and respond. Mechanism of RAG. First, it will in will have the pre-retrieval stage where we collect the data and structure the data and store the data. After that, we retrieve the data. Like when the user asks the question, it will retrieve the relevant data from the storage, vector storage, and then it will arrange it and send it to the, it will move to the post retrieval where it will get the other few short prompts and it will generate the output. I'll show it in better in architecture. In RAG, first we collect the relevant data like PDF, CSV, image, or video, audio, everything. And after collecting the data, we will pre-process the data so that if there is any missing data and all, for that we pre-process that or any bad words, and then we will be splitting them into chunks. For example, here I use the word chunks, like it will be, if I give the, if it contains the input as my name is, it will split up them into the different chunks. I will show it. Depending upon the chunk size, it will be splitting the whole sentence or whole PDF or documents to the relevant sizes. Here I used character splitter, and it will split the into each four characters, like 1, 2, 3, 4. In the space is included. And in chunk overlap, if I put chunk overlap as 1, it will give the first chunk. It will have first three of its own, and the last one it will share with the second chunk. And in second chunk, it will have the first one as from the previous chunk, and the last one for the next chunk. So it will have 4. Here it will be 4, and it will be 4. Why do we need overlap? So that we don't miss some of the words. So for that purpose, if I put 3, if I put chunk size 5 and chunk overlap 0, now 1 is a full word, it is in that chunk, and O is in the first chunk, and F is in the second chunk. So the meaning of this word is gone. So to overcome that, we use the chunk overlap. After chunking, we convert them into the numerical representation, like shown in below, like different numbers of systems. Each chunk will be split into the numerical representation, and it will be stored in the vector store. Whenever the user gives the input, user prompt will go to the embedding, that is, it will be converted into the numerical representation, and it will fetch that relevant data from the vector store, and that relevant data will be moved to the argumenter. Then those retrieved data will be moved to the argumenter. And now what argumenter will do, that it will have some few prompts, like few of prompts, like how it should behave, what are the behavior for the LLM, and it will have the user prompt to as the input, and taking all this, and it will send it to the generator, like GPT-3 and all, and it will generate the relevant output for the user input and retrieved data, and as a in a format of given prompt. Like I showed here, external data. These are the external data. It may be of any data like publicly available web script data or government data, crowd, crowd collected data like surveys in social media and all those kind of things. After that, what we do is that we pre-process the data, because there will be some of the text like this, you can see here, and some text like this kind of words. These are irrelevant words, and while there will be an empty line, remove all of them, we pre-process the data. There are several steps of cleaning the data, like handling the missing value, scaling the numerical features, etc. As I showed you, chunks is nothing but we are splitting them into the small parts, so that it will not get loaded to whole thing. If you put everything on the one, it will forget everything. Like if you put here a long story, then it will be missing some other topics. So for that, we split them into chunks. There are several types of chunking, like sentence-based chunks, paragraph-based chunks, fixed chunks, and What I showed here was character splitter, like each character can split into each characters. See, this is a chunk size of 1. After splitting them into chunks, it will be converted into the embeddings. Okay, I didn't add that. Embedding is nothing but the numerical representation. After converting that into the embeddings, we store that in the vector store. So the vector store is nothing but we can where we can store the different types of data like image data, text data, or any other type, video data, everything. What the specialty is that it will store in the numerical format, so there will not be difficulty in storing the data. Other models database there are some issues like the data should be some in this format. These images should not be added like that. There are several other vector databases like Fuzzy, Pinecone, Chroma. Coming to the vector embeddings, it is nothing but the one which I showed here, the numerical representation. There are different types like sentence embeddings, document embeddings, word embeddings. Here you can see that image can be represented as three three colors, and each color will be of different color representation. And each chunk, whatever you see here, each chunk will be of having a 384 dimension or 796 8 dimension, etc., depending upon the model which you used for embedding. Coming to the vector indexing, it is nothing but how we are storing the vector database. It is nothing but arranging them in the storage. Like as you can see in this supermarket example, each items are stored in different section like bakery section, cleaning product section, dairy section, and they are arranged in perfect way so that we can get access to the very quickly. Like if you want any milk, you can just pick it up from that section. Go to the dairy section, pick it up. So in vector indexing, it is nothing but organizing the uh, here whatever the output it generates, it will be organized way, stored in organized way, like so that we can retrieve it very easily. Like wolf, dog, cat, everything is here. It is stored under animal section. Fruits are in food section. You can see that apples, bananas, everything are together. When are you give the query like I want something like if I give input as pineapple, it will go around here and search the relevant data. Indexing nothing but storing the data, like arranging a showed here. Coming to the vector search, it is nothing but searching the data with the similar meaning of it. Example, you can see here, given the input as motorcycle, and it will retrieve the relevant meaning based data like motorbike, bike, bicycle, not the keywords. If I give here query as a kitten, input as a kitten, it will go to that section where there is cat, dog, wolf in that section. Like if I give here I give input user prompt as an milk, it will go to this section and retrieve that. It will show that.
Hello, Vijay.
Yeah,
Vijay Fawaz here. I have a doubt.
yeah,
Yeah. See, you said that the texts are broken down to different chunks, right?
yeah.
Yeah. So in this case, for example, if we have a word called animal, okay,
Okay.
it might be using different chunking algorithms. It might be broken down to two different what chunks, right?
It depends on what we use.
Sorry.
It depends on what we algorithm we
Yeah,
give
correct,
as
correct.
input. Yeah,
So let's consider that animal, the word animal has been broken down to two different chunks. Okay, so during the in the vector database, it won't be shown as animals, right? It may be
yeah,
Annie as one
yeah,
chunk and Mel as a different one, right?
yeah.
Yeah. So
You can give it
how?
here.
Yeah. So my question is how it will be placed along with dog and cat.
Uh,
Yeah. Here.
your example is animal, right?
Yes, correct.
Where we are going to give some chunk overlap so that to overcome that. Here, for example,
Yeah.
TEND, tend,
Yes.
is split into T and end. So what chunk overlap do is that it will give the give some it will get some words like most of the time it will be like this, like it will overcome that. The different outcomes, the companies, the high growth rates, will go up to till here 64. So the 10 and 2 both comes under chunk 1 as well as in chunk 2.
Yeah.
So if it is not able to find it on chunk 1, then it will be stored in chunk 2, and it will find the similar meaning. It will make sure that if that is missing, then it will neglect that. It will put it somewhere else.
Okay.
For your example,
Okay. Okay.
most of the time we don't go for a very low chunk. We'll
Okay.
go to 100 or something like that. Chunk overlap 100,000, these kind of things for a longer PDF. And chunk overlap will be around 100, 200 like that. So that there will not be any missing.
Okay. Thank you.
So in vector search, this is the thing what it happens. If we give the computer as a input, it will give the relevant, meaningful, words. It will not be searching as a keyword like microcomputer, laptop, mainframe. These are somewhat similar linked to the computer words. That's how it is generating. If I give the input as a kitten, it will search near that cat area. Where is the cat? It will go to the animal section. That it will go to the cat section. That's how vector search is happening. There are other searches too, like keyword search and all. But in the vector search, it is mostly and we do the similarity search. That is the meaning of that. It will, if I put kitten, it will not find the word kitten. Instead, it will find the any other words related to that meaning of that. There are different mathematical operation types like Euclidean, Manhattan, cosine similarity. In Euclidean, there is a it is nothing but the distance between 2 points, and Manhattan it is nothing but the difference between the 2 points, absolute difference. And in cosine similarity, it is nothing but the angle of it. As you can see, the use of prompts comes. It will be split into. It will move to the two sections. One is the vector storage. Now is the argumenter. It goes to the vector storage so that it will search the relevant document for that or chunks for that for the input. What happens in the argument is that we'll write some prompt like I showed you in few short prompt example like that. I will give the some instructions like you have to are the input will be given, kind of inputs will be given. These are the outputs which I expect, that kind of things. Using that prompt, it will be go into the argumenter, and argumenter will receive the user prompt like the original prompt the user given, and it will take that. Also, it will take the output of the vector storage, the semantic search which happened. It will receive the all the uh, chunks. It will not retrieve the embeddings. It will retrieve the chunks and its ID. ID means unique ID. That is, we give that number. Here is the my is the one ID. Name is the second ID. Is the third ID. In this example, chunk one, chunk two, chunk three, like that. That will be go to the argumenter. Argumenter will be sending that into the generator by will tokenize that input, and it will send that into the LLM, and LLM will generate the response depending upon the user prompt and its relevant data retrieved from the vector store. And using the few short prompt examples, it will generate that relevant output. Like I want to the output should be in this kind of format, in JSON format. Give me the output in JSON format. It will generate that output in that kind of format, and it will send it to the user. So the RAG has different applications like for customer support, test completion, advanced answer, question and answering, like that. I will show you the code. I will upload an PDF file which I downloaded, and just press here. Before that, you have to run this part. You need PY PDF to read that and go through this link. so that you can get the idea of it, how to use that pip install PDF from PY PDF, which what are the things we have to import, how to read the PDF, how to go to the iterate through each pages, everything. Here you read the PDF, then you iterate through the each pages of the PDF and get the text. This is just printing the whole text. It is retrieved all that data from the PDF. So here I splitting them into chunks. I use the lang chain. And I used character text splitter, which I mentioned before, like in this example. You guys can refer this link. So how to use them. This is the lang chain website. See here you can see that I have given chunk size of 200, chunk overlap as 20, so that I will not miss those kind of words. Almost everything, all the words will be stored in that. So 200 characters of words will be stored in one chunk, like each here wolf, dog, cat. These are all one chunk. Means the wolf is one chunk, dog is one chunk, and cat is one chunk. Similar way, in my here in example, 200 characters of words, like 200 characters will be one point here.
Yes, yes. It means Vijay is trying to explain there might be a single word or single letter or a sentence. So it will depend on how much the character size you are choosing, the chance it will be.
Here I splitted the text into chunks and just printed the first chunk. Like you can see, this is the 200 characters of chunk. Then I am converting it to the embeddings, like numerical representation, like I showed you here. Like this is the one chunk, second chunk, and third chunk will go to the embedding model. It will be there in output layers. I'm using the sentence transformer. You can go to refer this, how to use that. And using all mini L6B2 model for chunking embedding. Embedding is nothing but the encoding. Here I encode that. and I'm using Chroma DB for storing the vectors. To all these numerical characters I will be storing in Chroma DB because it is open source and easy to use. And refer this link how to get started. First, I have to create the client of the Chroma DB. Then I have to give the name for the that collection where it will be stored. Here, I creating the ID like what I said here for each chunk 1, chunk 2, chunk 3, like just test that what are the how many metadata. Metadata is nothing but the here metadata is nothing but the document. Like in this example, this is the metadata text of 0 which I generated, and embedding is nothing but relevant numerical representation, and I am giving the ID so that it can be retrieved very easily. Here I upload that to the vector database. I will give the input like I'm the user, and I'll give the user prompt. Prompt is what is modular RAG, and I will encode that so that I can retrieve relevant data from the vector store. Here is do the vector search. So it is generated, it to generate two results. So it generated two results from document 84 and document 95. This is the number which I given. Like I mentioned here, chunk 1, chunk 2, similar one. Chunk. For the relevant data it has generated. So it is generated topic about modular RAG, retrieve data. This is hidden. I use bits and byte and accelerator so that I can run it on 4 lakh. It is nothing but 4-bit quantization and acceleration means that so that you can use the GPU. This is a similar one which I mentioned before. Here to 4-bit quantization. These are some issue which occurs. For that we have to go to the runtime and restart the session. It has not picked that installation. That we have to rerun the whole thing. how to use Mistral 70. You can go through this link. It has got all the event documents. But for Colab, you need to have some modification like orbit quantization, accelerator.
Vijay, we can close the session in 10 minutes. Okay.
Okay, this will finish in 5 minutes. Nothing but
Okay, sure.
just the model takes the time. After loading the model, where it is this nothing but the output will be like whatever you retrieve the data will be in this format. So retrieve only this text like modular rack builds and frontage rack, these kind of things. Retrieve only that. I use this code. So you can see that it retrieved only that text. Here I am creating the few short prompt template using the LangChain, and I give the examples like it should be in better format, else it will be difficult for it. Like input, what is RAG, output, answer to that, what does RAG work, and answer to that. These are the examples, and I create the template, example template, and create the example prompt for LangChain. And create the prompt template. It will have the few short prompt template where we are going to the give the format and the example, that this example will go here and it will go here, and this word input should be replaced by suffix q, and I send the input prompt to this prompt template so that the input will go here. Here I tokenize the prompt and here I generate the output. Here you can put given some example. Same copy pasted same the user prompt. Can you just use that the word prompt here? Give this word variable as input here. If I don't give this, write this code, else it will generate all other answers. Like the in chat GPT models, it will generate only the output. And in open source model, it will give the output with the user prompt, uh, the example prompt, and the output, everything. This code is just formatting so that I can get only that particular topic. That's it. Any question?
Thank you so much for this very nice overview. I have a question. Like in this whole process, which is the step where this augmentation is happening?
Argumentation is nothing but it will be getting all the input and taking to the LLM. It is just not like in you may see in old offices, like there is one guy will be taking file from one table to another table, and it will collect everything and it will distribute and go to the LLM. Like in school, teachers will collect all the answer sheet and take it to her office.
And can you just go back to the vector step?
In code,
Like when the vector search, we're doing the vector search
this one.
in the notebook, the RAG notebook.
Yeah.
Yeah,
In this.
this one. Yeah. So can you just explain what's happening here?
Here it is nothing but uh, till do the semantic search, like the meaning of the user prompt. Here the user prompt comes and it will be stored in the prompt and it will be encoded. Like it can that so that it will be understandable to the vector store. Whatever in vector store is stored is in the form of the numbers with these chunks. And whenever the user prompt comes, it will be converted into embeddings, and those embeddings will be matched. Okay. That's how vector search is happening here.
So what are these like when you said number of results is two? So this is the two documents that are being created, like this
Yeah,
ID doc
the
84 and
two
95.
outputs. The two outputs.
Okay, so this what is this
Now,
doc
what is
84 and
like
95?
what is modular rack to retrieve the relevant document? Okay, it can give anything like 3, 4, or 5, anything. It will generate 5 documents for that element.
Okay, so when it is printing the result, so any one of these will be like can be
Not
the
this
result.
one. That LLM will be manage that, like
Okay,
rephrasing everything,
okay,
pre-text modeling everything.
yeah. It's better
This will
now.
be the just input to the LLM, these text.
Okay, I get
So in
it.
that, it will create new one.
Thank you. I got it.
Yeah. But if you change 5, then here you have to change the tokens.
So here we'll have to increase the number of tokens when
Yeah,
we.
increase the number.
Okay.
Else it will give some error.
Okay.
I will